Right, Edx M2 January 2011, question 5, on the topic of centre of mass. Here's the question. Pause the video and have a good look at it and think how you would divide this up into shapes for which you know the centres of mass. Ideally, you want to make up a table of masses and the positions of centre of mass. Here's what I've done. And I'll admit I pasted that table in from the mark scheme because it was very tidily done. Let's just check whether you've divided it the same way. It doesn't matter whether you used exactly the same rectangles. Here we've got one rectangle on the bottom and a triangle at the end. Here's another rectangle and a triangle at the top. And we're going to use the areas as the masses, and we need to work out the coordinates of the centres of mass. That's what these little green blobs are. But first of all, pause and check, is there symmetry? Because if there is, it's going to help, and we might not have to find, well, we won't have to find both the x and the y coordinate of the centre of mass. There is symmetry. The centre of mass lies on this line. If we call that the origin, this is the line y equals x. So the x and the y coordinate of the centre of mass, which is here, are the same. One more thing to tell you, or to check with you. As far as triangles go, the two little triangles, we need to know where the centre of mass of those are. And let me remind you, in case you need reminding, here's one of the triangles. This side is 9. I've shown this median from the midpoint of the side to the corner. The centre of mass of a triangle is 1/3 of the way up the median here, 1/3 of the way up. So by similar triangles, if the ratio of this side to the whole side is 1:3, the ratio of this bit to the whole bit is 1:3. The whole lot is 4.5 here, so this is 1.5, and this is 3 here. That's how we're getting the coordinates of the centres of masses of the triangles. Having done that, it's a simple matter now to take moments and say the total moment of the whole thing, mass of 12. They've simplified the masses by just looking at the mass ratios. So it doesn't matter whether you do that or not, it just makes life easier if you do. So instead of going with 243 and 40.5, take 40.5 as the unit mass, divide by it, and then they become 1, 1, 6 and 4. Okay, taking moments, here's the moments equation, check that. The answer from that equation is x bar equals 11. So it follows that y bar is 11. So the coordinates of the centre of mass, that point there, is 11, 11. Right, and that's it for the first part. Now for the second part of the question, they want to know, and this is a very common question as I'm sure you realise, they want to find the angle that the thing will hang at. If it's suspended from A up here, they want the angle between the vertical and the side AB. Well, the vertical will be the line from A through the centre of mass, which is AG here. So we want to find this angle, theta. And it's easy because we know where the centre of mass is now. This was the x bar, this was 11, and this was 11. So this one here, this distance here is 25. So tan theta is 11 over 25, giving theta is 24 degrees. And that's it. As far as the mark allocation is concerned, let's have a look here. I'll put the marks in green as I've already written in red. For identifying the masses and the centres of mass and the masses, there was marks for that. There was a method mark for the moments equation, and an A2 for putting the right distances in that moments equation and the right terms. And then there was an A1 mark for x bar and an A1 mark for y bar, giving 7 marks in total. And for the second part of the question, for the angle, there was a method mark for identifying the triangle. I'll put the method mark here, M1 for that. And then there's a method mark for getting an accuracy mark, I beg your pardon, for each of those. Okay, and that's it done. Thanks for listening.